Algebra 3. This is lesson 14. Lesson 14. Lesson 14 starts in your book on page 108. And it includes a bunch of stuff. It includes sine, cosine, and tangent. It includes angles of elevation and depression, rectangular and polar coordinates, and coordinate conversion. That is a lot of stuff to look at. Let's see. So to start out with, you guys need to and should already know coming in here, whether you came in from Algebra 2 or Geometry, you guys should know sine, cosine, and tangent, right? But you don't. All right, I'm getting some head shaking back and forth that I don't know this, I don't get it. All right, let's go ahead and take a quick refresher course down memory lane. All right, sine, okay, or we shorten it to sin, okay. We are going to write as so because it is sine equals opposite over hypotenuse. Okay, sine equals opposite over hypotenuse. All of this, what we're doing is we're going to be working with right triangles, okay, which is why we have a hypotenuse. We can't have a hypotenuse without a right triangle, correct? We got that. Cosine is ca, C-A-H, okay, because cosine equals adjacent over hypotenuse. Okay, and then we have tangent, okay, or TOA. Okay. Oh, sorry. Tan. Tan equals opposite over adjacent. So the SOHCAHTOA TOA is my mnemonic that allows me to remember what is over what in this particular instance. Okay. If I have a right triangle, okay, the first thing I have to know before I can use SOHCAHTOA TOA is what angle I'm going from, and it's always an acute angle. So we're going to use our little symbol theta down there. If theta is there, okay, my hypotenuse is always in the same spot, right? It's always the side that's opposite the right angle, and I'm going to assume that you knew that, right? So my hypotenuse is always there. Doesn't matter where my angle is that I'm using, hypotenuse is always there. Okay, do we understand that? Okay, but as soon as I know that theta is here, now I know that opposite is here and adjacent is here. Now, you may struggle to know which side is adjacent, but you should never struggle to know which side is opposite. Right? Can we get that figured out? That opposite is opposite. You're going to go directly across. Let me give you a verbal description of opposite. The line segment that represents opposite will not touch the angle. Okay? Notice how the adjacent side touches my angle, and the hypotenuse side will touch my angle. The opposite side will never touch the angle that I'm using. Okay? That's what makes it opposite. Does that make sense? So here's the thing. If you know where the hypotenuse is, and you know where opposite is, there's only how many sides to a triangle? Three, right? So if you know what 2 out of the 3 parts of the sides of the triangle are, do you know where adjacent is? It's the one that I wasn't sure of, right? Okay, so hopefully that makes sense. All right. Let me pause here. All right, so let's try to answer one of these questions. All right, it says angle 1 is 61 degrees, C is 10. We want to find the measure of side A. Okay, so we know 61 degrees. My hypotenuse is 10. I'm looking for this guy right here. Does that make sense? Yes? Okay, so from my angle, let's see, what are we looking for? Is this different than, oh, I got, for one, I've got, it helps if I put things in the right spot. I was wondering why that wasn't looking right. This is 61 degrees. So I'm going to look at what it is that I have so I know which trig function to use. I'm looking for A. I have my hypotenuse. What is A in relation to angle A? Opposite. So I have opposite and hypotenuse, so I'm going to use sine. And what comes after sine is my angle measure. So sine 61 equals A over 10. Does this make sense? It equals opposite over hypotenuse. At this point, I'm going to solve for A like I normally would solve for A, which means I'm going to multiply both sides by 10, right? So I'm going to hit 10 sine 61 degrees. Now, what I have to make sure of whenever I go to use my calculator, and I will have to use my calculator for this, is the first thing I need to check on is my mode, right? So I'm going to hit mode, which is right underneath the word quit. And notice how whenever I come down here, radians are selected. That's the natural tendency that your graphing calculator will have, is to select radians. Even though we use degrees far more often, it's going to probably have radians already selected. So I'm going to go ahead and hit enter on degrees and then hit second mode again. Now what I'm going to do is I'm going to type in my little function here, 10 sine and 61. I don't have to do anything else but close up my parentheses, and I get something. They wanted me to have my answer to the nearest tenth. So it looks like it should be 8.7. 8.7. I should get A for that. Okay, does that make sense? Can we do that? All right. Let's look at question number 2. All right, come down here. Question number 2, in the right triangle below, 12/13 represents which trigonomic function? All right, so we know we have 12 over 13, right? So let's look through this. All right, we know that we have to use a hypotenuse, correct? Because 13 is my hypotenuse. Which trig function does not use hypotenuse? Tangent. So I can automatically eliminate that one right there. So this one says sine of B, all right? Sine of B. Sine of B would be opposite over hypotenuse, which would put 12 over 13, right? So that should work, correct? If I went over to and I said sine of A, that would be 5 over 13, correct? All right, or if I went cosine of B, that would be adjacent over hypotenuse, that would be 5 over 13. So we see why not only why our question or why our answer is right, but why the other answers are wrong. We follow? Okay, great. All right, the next thing we're going to cover is angles of depression and angles of elevation. Again, this is old information. I'm going to try to hurry through this as much as I can because questions 6 through 10 is new information. Okay? I'm going to trust that you guys have this in front of you, so I'm going to move to another page where I can actually draw a picture of this. Okay? All right, anytime we're talking about an airplane or a bird or something that's up in the air or somebody that's at a higher elevation, we're automatically talking about angle of depression for the most part, okay? So if I'm up in an airplane, right, here's my, okay, there's my airplane, okay? His line of sight comes out like that. Does that make sense? Okay? An airplane flying at an altitude of 6,000 feet. All right, so he is 6,000 feet above the ground. Okay? All right, and he sights an object on the ground at an angle of depression of 23 degrees. There's my object on the ground. His line of sight drops 23 degrees. So that's where that angle is. Okay? Every problem dealing with angle of depression that I've come across has looked like this. If I have my right triangle with my angle down here somewhere, dealing with an airplane or a bird or something, I've probably done it wrong. Okay, it's not that you can't solve it that way, but you're going to have to invert some things. Okay? Next thing that we need is we need to see what they're asking for. In this case, they're asking for the slant range. That means they're looking for the direct distance at that slant downward. So we're looking for this. All right. So what we have to determine is, what do we have? What am I looking for? Which trig function am I going to use? Okay. What is 6,000 in relation to my angle? What is x in relation to my angle? hypotenuse, right? All right, so we're dealing with opposite hypotenuse, so we're going to use which trig function? Sine. So we're going to say sine 23 equals opposite 6,000 over x. Okay, this involves two steps to solve this because my variable is in the denominator. So what I have to do is I've got to multiply by x over x. So that gives me x sine 23 equals 6,000. X sine 23 equals 6,000. Now divide by sine 23 to get x by itself. All right, what I'm going to type in my calculator is 6,000 divided by sine 23. Okay, and I should get something in the ballpark of 15,355.83 feet. Is that what you got? Do you have a calculator? We still don't have one? We're like 5 weeks into school, we still don't have one. Why don't you have one of these over here? Christian? All right, does everybody have that answer? We know how to get it. Okay. All right. Questions 4 and 5 follow along the similar lines. I'll give you your answers for 4 and 5 so that you guys can work those out in your own time. 4 is going to be a little different. We'll look at 4 actually, because 4 talks about a slide. Okay, slide from a profile looks kind of like this. Okay, which means my right angle is down there. All right, a slide 5.5 meters long. Okay, let me find that. 5.5. So the slide portion of the slide is 5.5 meters long. Sometimes it's hard to determine what it is. It makes an angle with the ground of 25 degrees. Okay, so it's an angle of elevation. So elevation is from the ground up. Okay, that's where a lot of people get confused because we think if we're up in the air, that's elevation. No, elevation happens from the ground up. Okay, depression happens from the air down. Okay, at least in these questions. Okay. All right, we are looking for this. Again, it's opposite over hypotenuse. We're just looking at it a little bit differently, so it's still a sine function. So sine 25 equals x over 5.5. All I have to do is multiply sine 25 by 5.5, and that should give me my answer of 2.32. Okay. Number 5 is just like number 3, so we're going to move on. Okay. Which brings us to this, which is describing the vector using polar notation. Okay, this we use unit vectors. It's a little different here. Go in your book to, and I wish that they had separated this out a little bit. On page 110, I really wish that they had made rectangular and polar coordinates a totally separate lesson, but they don't. All right. What polar notation does is it takes the length of my line segment or my hypotenuse and then puts it outside the degree measure. Okay? And then it lists it, we can also list it like this, where this is my hypotenuse and this is my degree. Okay? Either one of those end up working for polar notation, even though they look similar to coordinate notation. Okay? The other thing that they use for this is they'll use I for my x direction and j for my y direction. Okay, that stuff's up there. You can go back and review the video when you want to get a look at that. But that's essentially what's going on here. Okay, so for number 6 really isn't a terribly hard question. My hypotenuse here is 3. Okay, and the degree is negative 214 degrees. Okay, that's polar coordinates. Okay, hypotenuse, length of my line segment, and my degree. Okay. questions about that? Okay. We could have also written it off as 3, comma, negative 214 degrees, parentheses. Either one of those methods will work. Okay. You guys should already know that this is negative because we are going clockwise from my initial point. My initial always starts from here, okay? And then we go clockwise or counterclockwise from there, giving me a positive or negative degree depending upon which direction I'm headed. Okay. Number 7. What is the hypotenuse of number 7? Okay. Let's see. Number 7 says describe the vector using polar notation. There's more than, oh, okay. So what they're looking for is actually this line. They want to know what the polar notation of that blue line is. And here's the tricky thing about it, is that when we have... Okay. It may not make a lot of sense to you, but when we go from this red line to the blue line, and the blue line is this dotted line, and it flips across to an opposite coordinate, the hypotenuse changes from a positive to a negative. Now, we know that there's no negative distances, but that's what we're referring to as the opposite of it. So it's negative 9, okay? Or better yet, because we're working with our blue line, let's use a blue number, negative 9, and then we need our coordinate, okay? But we're still going from here to here, okay, which is 234 degrees, and we know that because they tell me that. Okay, do we have any questions about that? No? All right. Try to get down to this last part, which is 8. Okay, let's slide on down. 8. This is what we call rectangular coordinates. Basically, we're saying our x is 3 and our y is negative 7.2. That's not hard. Okay, the x is the i's, the y is the j's. Okay, but we want to convert this over to polar coordinates, so we need a hypotenuse and we need an angle measure. Okay, so the way we're going to do this is we're going to look at it like this. Okay, let's see, 3 would be to the right, and negative 7.2 is going to be down here, correct? Which is going to give me this line. All right? So I can create a right triangle here where this is 3 and this is 7.2. The first thing that I need to do is I need to know what the hypotenuse is. Okay, we find the hypotenuse by using the Pythagorean theorem, right? Okay, so that's 3 squared plus 7.2 squared, and then we're going to square root that answer. All right, Christian, you got a graphing calculator now. Can you tell me what 3 squared plus 7.2 squared is? $60.884. Can you square root that for me so that we know what our hypotenuse is? $7.8. Okay, 7.8. So 7.8 is my hypotenuse. Now we have to find out what the degree measure is, okay, of 7.8. So at this point, what I can actually use is I can use my trig functions, okay? Notice that I have, based upon this angle, I know the opposite and the adjacent. So which trig function would I use? Tan, right? Except because we have those elements and we're looking for the degree, what we're actually going to do is we're going to use the inverse tangent of 7.2 over 3. And that's going to give me my degree measure. Okay, inverse tan, so you hit second tangent on your graphing calculator, and then 3, hold on. Yeah, should be. Okay, yeah. Go ahead. Anybody? What did you get? 67.38. Okay. So this degree here is 67.38 degrees. Okay, notice what this says. It says write 4 forms of the point. So this is why this question is going to take so long. All right. This is technically negative 67.38. Does that make sense? Because we're going here down and we're going clockwise. So we got negative 67.38. Okay? If we want a positive degree, we actually have to go around the other direction, right? So because that would complete the circle, okay, all we have to do is take 360 and subtract 67.38 from it. What do I get? Say it again. Okay, 292.62. All right, now they want the other one. All right, well that's still 7.8. Actually, we're going to refer to it as negative 7.8 and negative 7.8. Okay, so we're out over here. Well, we know that vertical angles are congruent, so this is 67.38 as well. Okay, so it is 67.38 from being 180 degrees, right? So I can take 180 minus 67.38. You get like 112.6, 112.62. And then I can go around the negative direction, which is 180 plus 67.38. Which should be something like negative 247.38. Okay, does that make sense? Do we see how we can get 4 polar coordinates? Because you have your positive hypotenuse and the clockwise and counterclockwise degree. Then you have your opposite hypotenuse, which is negative, and its positive and negative degree measure. Do we get that? Okay. Now, that's basically what's happening in number 10. We won't have enough time to do number 10 today, but I do want to do number 9, which is taking polar coordinates and getting rectangular coordinates out of them. All right? All right, and I believe it says 9 150 degrees, right? Is that what it says? Okay, so that tells me I know 150 degrees is going to be over here. I know the length of this is 9. Does that make sense? So the question is what are the x and y coordinates? So the question is, here's x, here's y. You know what I know about x, though? I know that it's negative. I know my x is going to be negative because it's on the left-hand side of the y-axis. Correct? Okay, so let's start with one thing at a time. If I want to find, and that's going to be my angle that I'm going to use, y is going to be opposite over hypotenuse. Okay, so tangent equals y over 9. We don't know, but we do know if this is 150, this is 30, right? So tangent 30 equals y over 9. So 9 tangent 30 equals y. What is my y coordinate if I have 9 tangent 30? 5 point, hold on. What did you say it was?
Well, I have 5.19.
9 sine 30? Oh, hold on. Oh, it should be. I way messed up. That should be tangent. Because it's opposite over hypotenuse. So, sorry, sine 30 equals y over 9. 9 sine 30 should be what, 4.5? All right, and you're going to do the same thing with cosine, and you should get, it'll end up coming out to negative 9 radical 3 over 2. Those are going to be your x and y coordinates. All right, not enough time, but hopefully you guys got something out of it.